Namaskar. So let us try to understand the SPI interface with a microcontroller. So we have studied, like UART and I2C, and we have seen the examples also using these two, right? Now we'll start with SPI, which is Serial Peripheral Interface. So you already know that SPI has four signals. Well, first is clock, second is chip select, third is MOSI, that is master out serial slave input. Okay, slave master output slave input, or fourth one is master input slave output. In this Texas Instrument microcontroller, it is written as PICO. Okay, that is peripheral input controller output. So controller means master, okay, and peripheral means slave. So this is how it will be denoted. So pico or poki. Okay, so it means this is my master, that is controller, and this is my slave, that is peripheral. So these two will be like used interchangeably, Mizo and Mozi, or Pico and Poki. Okay. All right. Let us proceed. In this microcontroller, first of all, we have to understand what are the pins dedicated for SPI signals. Okay, that we have to identify. So identify those pins which are dedicated for SPI, and then assign those pins to particular functionality. Okay. So first we will identify, then we will do that. So let us open the data sheet. So once we open the data sheet, I had told you go to pin attributes. So you can come to this data sheet MSPM0L1105, and if you see in pin attributes, you have a functionality SPI, and they have been clubbed together all the pins. So we have SPI CS0, CS1, CS2, CS3. So there are four chip select pins. So any of four, you can utilize. Okay, I am going to use VSSOP20 package. Next, we have SCK lines and POKI line and PICO line. Okay, so first of all, let us start with peripheral input controller output. Okay, so what are the pins that is available? Pin number 14 and 20. So if I try to assign pin number 14 and 20, let us go to there, or what I'll do is I'll just take a snap of this and keep it there so that it will be easier for us to point out. So okay, so our aim is to go to this Poki line. Poki line is sorry, Pico line. Pico line is 14 and 20. So you see pin number 14 and pin number 20. So pin number 20 is already used as UART X. So I will use this one. Okay. So this one I will use SPI Pico. Okay. So peripheral input, controller output. That is controller output means master out, serial in. This is MOSI line. Okay. So SPI MOSI line we have identified. Understood. Next, coming to the fact that POKI line, that is peripheral output, controller input, that is MISO line, master input and control slave output. So that is, you can see pin number 1, 9, 12 and 15. So any of these two. So pin number 1, that cannot be used. Pin number 9, yes, it can be used because I have assigned here SPI POKI. So pin number 1, 9, 11. 11 is used as SCL, I2C SCL, and which was the other? uh, Pin number 1, 9, 12 and 15. So if you see pin number 12, pin number 12 is used as some user button. This also can be used for SPI line. Okay, not a problem. So anyway, we will assign pin number 9 for my POKI line, that is must peripheral out, controller in, that is MISO line. Okay, so these two have been assigned. So this is how you identify the pins and assign them in the microcontroller. That's how you make your circuit design little easier. Let us proceed to next line, which is clock line. So clock line, if you see SPI SCK, so clock line is 10, 11, 13. So go to this pin number 10, 11 and 13. So what I'll do is pin number 10 I'm using SCK line. Okay, pin number 13 can also be used, sorry, let me see. Pin number 10, 11 and 13, right? So pin number, I'm using 10 as SCK line. Okay, so clock line is done. Now if you want, you can use CS lines also. Okay, so what I'm going to do is, instead of one CS line, I'll define here 2 or 3 CS lines. Okay, so if I see CS line 0 is pin number 8, and 1 is 4 and 13, and 2 is pin number 19, and 3 is pin number 2 and 18. Okay, so I have taken here pin number 13 as CS1 and pin number 19 as CS2. Okay, so pin number 19, if you go here, pin number 19 as CS2. Okay, so this is how you have understood the fact that how to identify the microcontroller pins for their SPI functionality, and how to assign those particular pins for your particular, like SPI interface. Okay, so basically you have multiple pins for the same functionality, SPI POKI, SPI Pico. However, only one of them you have to use. Okay, so this microcontroller is very, very, like powerful, uh, still having very less number of pins and very small low cost power, like microcontroller. However, this microcontroller is having almost all the functionalities, as I told you, like UART, I2C, SPI, even ADC is there. So all these things are there. So we have completed up to SPI today. And if you do have any questions regarding this SPI identification and like assignment of those pins, then you can reach to me on the comment box, and you can directly connect these lines to your SPI lines very quickly. In my next session, what I will do is, I'll take up some of the like peripherals. For example, I will take ADC and DSC and IO expander. So all these like devices, I will try to do the SPI like communication interface with microcontroller. So all right guys, thank you so much, bye.